A, B and C are 3 points in a straight line. A particle travelling along that line passes A, then passes B 4 seconds later, and passes C after a further 4 seconds. If the distance from A to B is 60 meters, and the distance from B to C is 100 meters, we want to find the acceleration of the particle and the speed with which it passed A, assuming constant acceleration. This is another situation where a clear diagram will help. So let's draw the points A, B and C in a straight line. The particle passes A with an unknown speed, but since this is the speed at the start of the motion, we'll call it u to represent initial velocity. Throughout the motion, it experiences an acceleration which we don't know, so we'll call A. But note that we represent A with a double-headed arrow. It passes B at 4 seconds after passing A, and C at 8 seconds after passing A, since we know that it passes C 4 seconds after it passes B. The distances A to B is 60 meters, and B to C is 100 meters. We now have a clear picture. We want to find u and A, and we need to use this information in order to solve that problem. To proceed, I'm first going to look at the motion between A and B. So collect information for A to B. As always, we collect using SUVAT. We know the distance between A and B is 60 meters. We don't know the speed, but we call it u. We don't know the final speed. We do know the acceleration is A, and that the time taken is 4 seconds. S, U, A and T can be found in S equals ut plus a half at squared. Substituting in, we get 60 is equal to 4u plus a half times the acceleration times the time squared, so 4 squared. This is 60 is equal to 4u plus a half of 16 is 8, so 8a. We can divide through by 4, giving 15 is equal to u plus 2a, and we'll call this equation 1. We'll now look at the motion from A to C. Collecting the information using SUVAT, as always. S is 160 meters. U is just U. A is A. And the time taken is 8 seconds. The 4 quantities under consideration are all represented in the formula S equals ut plus half at squared. Substituting in, we get 160 is equal to 8u plus a half times the acceleration times the time squared, and simplifying, this is 160, is 8u, and a half of 64 is 32a. All of these things divide by 8, so we can simplify this to 20 is u plus 4a, and we'll call this equation 2. These are the two equations, 1 and 2, that we found before. We can solve these simultaneously to find the values of u and a. Equation 2 take away equation 1 gives 5 is equal to 2a. Dividing both sides by 2 then gives us that a is equal to 2.5 meters per second squared. Substituting this value back into equation 1 gives 15 is equal to u plus 5, so u is equal to 10 meters per second.